Hello.
Good morning, sir.
Yeah, good morning. So we can start. So how many of you go through with the week 10 content?
Sir started but not completed all the lectures.
So from the starting, if you have any doubt, you can ask. So we will go through with the week content. Just tell me either we go to the week content or if you have any doubt.
Sir, no doubt as of now. I think I can ask later when I've completed all the lectures.
Okay, so I think week 10 will be the SR started from the SR latch. So uh, in the week 9, we start with the sequential circuit. So basically, sequential circuit where synchronization is important. And for the synchronization, we use one clock pulse that will synchronize all the operations. Okay. If you go with the applications part of the sequential circuit, so I think you are aware with the processors. Okay. That will be operate either if I'm taking the i3, i5 processor, so that will be having a frequency of 2.4 gigahertz. Okay, when you search a mobile phone or the laptop, you just check the clock frequency also. What is that clock frequency? That clock frequency will provide you that how fast operation will be performed. If the clock frequency is high fast, that means the one process will be complete in a shorter time duration, or we can say the in the 1 second, the number of process executed will be high. Okay, so it will be increase the clock frequency. For a better clock frequency, your processor will be better. Okay. So the first part for the sequential circuit is basically flip flop or latch or flip flop. But latch and flip flop is the one bit storing device. Okay. With the combination of flip flop, we can design a register. We can design a counter. If I am talking about the RAM, ROM, where we required a 32-bit processor or 32-bit storage device. So that means 32 bits flip flop is required. Okay, so simply latch and flip flop is a single bit storage element. Okay, so first we start with the latch. I think you go through with the latch. So in the week 10, we start with the SR latch. And then the flip flop. So the difference between latch and flip flop, anyone? latch basically the level trigger device. So synchronization is there, but poor synchronization. Okay, flip flop is the best trigger device. Okay, so latch will be the basically level triggered and the flip flop is the S trigger device. So in the level trigger device, the synchronization is possible, but it is a poor synchronization. How? Why? Because if I draw a clock pulse, this is my clock pulse. Okay. So if I say first of all the combinational, then combinational there is no boundary. Okay, you can start your working at any instant of time. Okay, so the complete duration to operate a performance is from this to this one. Okay, if I just take a two clock pulse, the combinational circuit will perform in this whole duration, any day. Now, if we go with the latch, okay, I'm taking the positive level latch, so that will be perform a operation in this duration and in this duration. Better that combination circuit, okay, better that combination circuit because combination circuit perform anywhere, latch will perform in this duration. Okay, if we are taking a negative latch, that will perform. Okay. Now the third is if I am talking about the flip flop either perform in the positive edge. I just take a short duration. Okay, that is the positive edge. And if I am taking about the negative edge, flip flop, so it will perform this duration at. Okay, so better synchronization in the case of flip flop. Okay, now if we design with the flip flop using NAND gate, so we require one NAND gate, one NAND gate. This one is two. Okay, according to the A and B, I just say we required a one Q and one Q. Okay, I assume Q is 0. This one will be 0. Okay, AB is 0, 0. So, what is the property of NAND gate? If any of the input is 0, output is 1. So, Q is 0, B is 0, that means Q bar. Sorry, this is the Q and Q bar This is the previous condition. And Q and Q bar, Q plus and Q bar plus. This is the next condition. Next. What is the difference between previous state and next state? Previous is basically the stored data. Okay, like for example, we use this circuit. Okay, and in this circuit, the Q will be zero, it will be stored. So we consider this is the previous condition. Okay, now if Q is zero, B is zero, we are getting one here. So that means Q bar is one in the next state. Okay, now Q bar one go here, A is zero, Q is also one. Again, A, B, 0, Q I assume 1 and Q bar I assume. So if it is 1, B is also 0. That means Q bar is 1, 0, 1. Q with B, so Q bar is 1. Q bar is 1 with A, it will be 1. 0, 1, 1. Q is 1, B is 1, so it is 0. This is 0, A is 0, so it becomes 1, 0, 0, 1. Both will be 0, 0, it will be 1. So Q bar is 1. 1 and A both are 1, so it 1, 0, 1. 0, 1. That means it will be 1. It will goes with this. So it becomes 1, 1, 0. Okay, so both will be 0. So Q bar is 1. And this one will be go with A, so it is 0. 1, 1, 1, 0. Okay, so both will be 1, that means Q bar is 0. Q bar goes with A, so it becomes 1. Okay, so I remove this one and remove this one. Okay, now I analyze from the data. When A, B, Qn plus 1 or Q bar, Q plus. Okay, you can write in any way Q and plus. So when you can check when both A and B are 1, 1. What is your previous input? If it is 0, your next input is 0. If it is 1, your next input is 1. Okay, previous is 0, next is. Previous is 1, So I can write as a Q1 plus 1 is the previous output. Okay. Now, when we apply in this two situation, A is 1, B is 0. So you can check either the previous input is 0 or previous input is 1. Every times you are getting 6. So that means output is always. If it is 0, 1, you apply any of the input, your output will be 1. Okay. Now, the problem with when you apply both input as a 0, either you apply 0 and 1, your both output will be 1. Okay, and we know that Q and Q bar both are complement to each other. So it is not possible that both output will be same. So when you apply the 0, 0, both input is 1. So I just say that this is the invalid. Or we can say that logic high. Okay. Now we go with the SR latch. So basically S is for the set and R is for reset. Okay, any doubt? Yes, any doubt? Okay. You can even though design the SR latch with the help of NOR gate. The NOR gate table is different from the NAND. Okay, so again, if I take the table, so as I'm not mentioning it as SR, I'm mentioning it as AD. A, B, Qn, Qn plus 1, Qn plus 1 bar, 0, 0, Qn is 0. Now the property of NOR gate is what? If both input is 0, then output is 1. So I substitute Qn is 0, B is already 0, so Qn bar is 1. Qn bar go with A, so A, this is 1, this is 0, so we are getting it. Okay, and when Qn is 1, so Qn will be go with B, so Qn bar is 0, and Qn bar is 0, A is 0, so we are getting 0, 1, it is 0. Okay, so B is 1, that means Qn bar is 1, sorry, 0. This is 0 and A is 0, so it becomes 0, 1, 1. B is 1, so one input is 1, so that means output with respect to this one is 0. This is 0, A is 1, so 1, 0, 0. Both will be 0, 0. So the output is 1, 1, 0, 1. Now A is 1, that means Q bar is 0. Okay. This 0 will be filled with B, so you are getting, so it is 0, and this 0 will be filled with a B, so you are getting 1. Now when both are 1, 1, okay, the one input is 1, so that means you are getting both output with it. Okay. So if you draw the set the value A, B, and Qn plus 1 or Q plus. So if it is 0, 0, your past input output is this one, your present output is. So we can say it is a previous or no change condition. Okay. When 0, 1, your input previous output is 0, 0, but you are getting 1, 0. Your previous output is this one, but now you are getting 1, 1. Okay. Your previous output is this one, but now you are getting both 0, and that is not possible. Okay, that is not possible. So we can say this is the invalid condition. Okay. Now if you compare the table, so with the NAND gate, you are getting A, B, Q, n plus 1. So 0, 0 is the invalid. 0, 1 is 1. 1, 0 is 0. Okay, 1, 0 is 0, and 1, 1 is 1, 1 is no change. With the help of NOR gate, A, B, Q, n plus 1, 0, 0 is no change. Zero one is one. 10 is 0, and 11 is input. Okay. Now, in the case of NAND gate, your invalid condition will be the logic type. That means your Q and Q bar both are 1. In this case, NOR gate, it is called the logic low. That means your Q and Q bar both are. So if you see in the books or somewhere else in the internet, okay, so we are basically what we are doing. We are just make both tables will be same. So what is the way is that if I use the A bar and B bar, if I use the A bar and B bar, so what happen? So it is a 1 1, 1 0, 0 1, and 0 0. In place of A and A bar, A and B, we are using the A bar and B bar. So that means what is A and B? A and B is this one. Okay. Now can you check that these two conditions will be same? 1 1 condition is same. 0 0 condition is same. Because in the 1 1 it is invalid, invalid. 0 0 condition it is a no change, no change. Only difference is here. Now it is a 1 0 it is 1, and here it is a 1 0 it is 0. Okay. So what we do now, in place of Q bar 2n plus 1, I just place 2n plus 1 bar. Okay, so that means in the NAND gate, in place of A, I am using the bar. In place of B, I am using the B bar. Here we take the Q, now I am taking the Q bar, and here I am taking Q bar, I am taking. So that will be equivalent to this. Now the both table will be same. Both circuit will be same. Okay. Now when the input is 0 1, we are getting output is 1. Okay. So this output is 1 is called the set condition. And output is 0, it is called the reset. Okay, so that's why it is called the set reset. Fine. After that, we want to control this particularly latch with the clock. Okay, so we required one clock. Now where we implement the clock. Okay, so this is the problem. So what we do, we have to require one more stage where we require the clock first. Okay, because it is already two inputs that we use. Generally, we use the two input AND gate, NOR gates. Okay. So we already use the two inputs. Now we require a clock first. So we implement see the NAND gate as NAND or clocks. So what is the output here? S dot clock bar. The output is R dot clock bar. If clock is one, if clock is one, so what we are getting simply S bar because S dot clock that means clock is one, so S dot clock is simply S and bar is available, so S bar. And similarly here we are getting R bar. Okay, yes or no? Any doubt in this one? Why and where we require the S bar and R bar? So in the NAND gate, we require the input as a bar and B bar. So that means S and R we apply with the NAND gate with the help of clock pulse. So I'm getting S bar and R bar. S bar R bar. Here I take the input A and B. Here I take the input S and R. So we are getting S bar and R bar. Now can I use this S bar and R bar in this circuit? So one is this one. Clock pulse. Q. Now what is my table? Clock is 0. I apply S and R any value that will be invalid. Or we sorry, no change. Why no change? If clock is not applied, that means there is no input changes will be appear. So output will be remain as it is. If clock is 0, that means you apply any of the input, you are always getting 0. Sorry, you are always getting 1 and 1. Okay. If Q is 0, 0 here, 1 here, if you are getting 1. If Q is 1, so 1 go here, 1 and 1, you are getting 0, so that is 0. So the input that you are taken in the previous state, that will be remain same. No change in that because your clock is 0. Now when clock is 0, 1, sorry, clock is 1, and now you apply the SR 0, 0. So what happened? No change. When clock is 1 and S is 0, R is 1, S is 0, R is 1, this value, this value. The output is 0. When clock is 1, S is 1, R is 0. Why I'm taking, this is my input now. Okay, you can see this table, we already draw this table. So in place of A, I put a S, in place of B, we are putting B, Y, R. Now here we apply the S and R. So that means it is S bar and this is R. Okay, now if we are getting 1, 0, so S is 1, R is 0, this way. So I am getting output is 1. Okay, and when clock is 1 and both will be 1, we are saying it is invalid. Okay, or logic. Okay, so we are not mentioning this condition because it is an invalid condition. Similar to the, if we are know about the K-map, there is a one don't care condition, so that don't care condition is this. Okay, fine. Any doubt? So this is the set, this one set. Okay, this condition occurs. This condition occurs when R is 1. Okay, R is basically reset. So reset is 1, then this condition is up. Okay, so that's why it is called the reset. This condition occurs when S is 1. So that's why it is called the set. Okay, any doubt? And then you say yes. Sir. Then After that, D flip flop. The name suggests it is a delay. D plus one. Okay. One more thing is that when we study about the flip flops, we have a three different tables. Can anyone tell me the name three tables? Generally, if we have a flip flop, we require three different tables for that. Anyone name these three tables? Okay. So just remember these three tables. One is the truth table. Second one is the characteristics table, and third one is the excitation table. Okay, in later classes, week 11 and week 12, this excitation table is very important. Okay, so first we know about the truth table. After that, from the help of truth table, we design the characteristics table, and with the help of characteristics table, we design the excitation table. Okay, so in the next week when we go, so this excitation table is very important part. Okay, so I just draw the truth table for D flip flop. The input is D. Out. If D is 0, Qn is 0. If D is 1, Qn is 1. This is a simple truth table. Okay. Now, if we are going with the characteristics table, along with the input D, we just take one more input is the previous. And on the basis of this one, I just draw the Qn plus 0, 0, 0. Okay, when D is 0, output is 0. D is 0, output is 0. D is 1, output is 1. D is 1. Okay, this is the practice. And third one is the excitation table. In the excitation table, we just assume that Q1 and Qn plus 1 is our input. Okay, and D is the output. From the excitation, that means from the output, we define our inputs. Okay, so both are 0, 0. D is 0, 0, 1. D is 1, 1, 0. D is 0, and 1, 1. D is. Okay, now with the help of this one, I can say that Qn plus 1 is simply D. From this one, I have to draw a K-map between D and Q. This is simple, so no need to draw a K-map. 0, 0, it is 0, 0, 1, it is 0. Make a group, and Qn plus 1 becomes D. Okay, and this one, I just create a K-map between Qn and Qn plus 1, 0, 1, 0, 1. So 0, 0, it is 0. 0, 1, it is 1. 1 0 it is 0 and 1 1 it is. Again create a group. So I can say Q1 plus 1 is equal to. Okay, so these three tables are important. We will discuss the excitation table application we will discuss in the next weeks, where we design the counters, FSM, finite state machines. So the excitation table is very important in that scenario. Okay, so for every flip flop, we can design this three type of tables. Okay, any doubt? No, I think the T flip flop. T is basically, as the name suggests, it is a toggle. Okay, when T is 0, Tm. If T is 0, that means Qn plus 1 is Q1. And when T is 1, so that means Qn plus 1 is Q1 bar. Okay, so this is my truth table. Okay, now I have to find a relation between T and Qn plus 1 that you can't derive from this. So for that one, we required a characteristics. So T and Qn is the input, Qn plus 1 is out. 0 0 0 1 1. Okay, so when T is 0, save. When T is 1, flip. Okay, so now if you draw the K map and find the equation, so you can find as a 2 and 1 plus 1 is Tx. So, okay, because it is a T bar Qn plus T Qn bar. In both situations, the output is 1. Okay, now we require the excitation. So Qn plus 1, 0 0 it is 0. 0 1 it is 1. 1 0 it is 1. And 1 1. And 1 0 1 1. So T is Q1 XOR Q1. Okay. Now if you draw the block diagram. Okay, so as I already discussed, two particular sequential circuit, like this is my circuit, two line, and second this is my circuit, two block and block. So this is the difference between two. This particularly is the level trigger. A simple straight line is called the level trigger. So that means this is the T latch. Okay, and this type of circuit is basically S trigger. So this one is the T. Okay, along with that, if we use one bubble, so it is called the negative as T flip flop. If you use bubble, if we are not using bubble, so it is a positive. Okay. Similarly here, it is a positive level T latch. If I use the bubble, it is the negative level T latch. Okay. Now this excitation table is also very important for flip-flop conversion. Okay, what is the meaning of flip-flop conversion? If I want to convert T flip-flop into D flip-flop, okay, or the D flip-flop into the SR flip-flop. So this type of conversion will also have done with the help of excitation table. Okay, so that is not in the video lectures. I think we are not going in much detail about this, but this excitation table is important for. Okay, any other doubts about this part? Any other doubts? So we can take one particularly waveform base. Okay, this is my clock. signal. Okay, this is my T and D flip flop out input. Okay, and I just say my Q is 0. Okay, that means previous condition Q is 0. Now what happened if I draw as a Qn plus 1 for T flip flop? Okay, so this is my positive edge. Okay, what is the output? First of all, if I take a T flip flop, so my previous will be 0. So I am just taking till previous is 0. Now when the positive edge will be appear, this is my positive edge. My positive edge will be appear at this one. T input is 0. So when T input is 0, that means no change. The output remains same. Okay. Again, positive edge appear. T is 0. So that means no change. Okay. Again, positive edge appear. T is 1. So that means output will be invert. Output of invert of what? Previous condition. Okay, when T is 1, output will be toggle, and toggle of what? Previous condition. Previous condition what? 0. It will be maintained till here. Now, when clock positive, T is 1. So output is toggle. Toggle of what? Previous condition. So this output is dependent on previous condition. So this is the T flip flop output positive as okay. Second Qn plus 1 T. Now I am taking the T flip flop output with negative edge. Okay, so where the negative edge will be coming, the negative edge will be coming here. Here. Okay, so my previous output is 0. That is coming 0. Now, when the negative edge, this is the negative edge appear, check T is 1. So T is toggle. So toggle from previous condition. Okay, now negative edge appear, T is 0. So 0 from previous condition. Okay, for this particularly clock, this is the previous condition. Okay, again the negative clock appear, T is 0. So T is 0, that means it is again a same as previous condition. Okay. Any doubt? Yes, anyone doubt? So what is the meaning of previous condition? Is the previous clock output. Okay, because in the next clock, the previous clock output is the previous condition. Okay, so now if I draw the Qn plus 1 for D flip flop with positive edge. Okay, so these are the positive edge. Okay, so previous output is 0. Now when clock is 1, it is 0. Okay, the output is 0 till next positive edge. Positive edge appear, output is 0, so again it is 0. Okay, till next positive clock appear, output is 1, so 1 till next positive, output is 1, so input is 1, so output is okay. And Qn plus 1 with D, we are taking the negative edge. So these are the negative edge. Initially it is 0. Now at the negative edge, our input is 1, so D till here. Next, negative edge input is 0, so output is 0. Negative edge input is 0, so output is 0. Okay. So for this one, this is the previous. For this stage, this one is the previous. Okay, so I think hope you understand what is the meaning of previous state and the next state. Okay, if I rename this particularly clock as a, that is the clock 1, that will be the clock 2, that will be clock 3. Okay, so in between this two particular instant, between clock 1 and clock 2, because positive edge will be appear here and negative have appear here. So at this instant, this one is the previous and this one is the next. So this one is the Q and this is the Q. Okay, understood? Fine. So we stop here. We will start in the Wednesday class some topics, and after that we take some doubts. Okay, I think hope till Wednesday you will cover all the video lectures. Thank you.
Thank you, sir.
Thank you, sir.